In this video, we discuss our question 10, a question on electrostatics for this November 2018 paper. In the description below, if you're interested, there are other links for our video created for this question paper. So like question 10, but two identical insulated spheres X and Y suspended by threads from a ceiling. So this black line is khombisa ceiling where the two spheres X and Y are suspended. These lines are threads where two are held at a small distance apart. So this is the distance apart to positive charge X and negative charge Y, as shown in the diagram below. So sphere X, which carries a charge of plus 4 times 10 to exponent minus 18 coulomb, while sphere Y has an excess of 30 electrons. That's why sphere Y are negatively charged. Ayafana lama charges lawa, but charge Y has an excess of 30 electrons, right? So la Google 10.1, but calculate the magnitude of the charge on sphere Y. So sphere Y 10.1, the charge on sphere Y, calculator using lama electrons I30. The reason why emphasize this thing, the reason why sphere Y are negative, it's because of lama electrons I30, right? So ngifuna ukwazi ukuthi lama electrons I30 ane charge engakanani, right? So sisebenzisa this formula, the number of electrons n is equal to the charge divided by the charge on a electron, right? So sina 30 electrons equal to the charge on that sphere divided by minus 1.6 times 10 to exponent minus 19, which is the charge on one electron. Ngifuna ukwazi ukuthi lama charge I30, right? Lama electrons I30 ane charge engakanani, which azoba equivalent to the charge on sphere Y. So therefore, after cross multiplication, Q is equal to that. So lana sizothi ke manje sizothi 30 times minus 1.6 times 10 to exponent minus 19. This is equal to minus 4.8. Q is equal to minus 4.8 times 10 to exponent minus 18. I think minus 18 coulomb. Minus 18 coulomb. So Q is the charge. So unit here to about coulomb, right? So the charge on Y is minus, which is basically the same as sphere X. The charge on sphere X ayafana, and same charges as well. The two spheres are now released. So bebawabambile sphere Y no sphere X besibabambile lana. So manje sengiyawareleasa ke manje 10.2. Now I'm releasing, the spheres are now released and they move towards each other. Give a reason why sphere X and Y move towards each other. It's because of opposite charges attract. They attract. Opposite charges attract. So a negative and a positive, they do what? They attract. Kubane attraction. There's the attraction, and then negative and a negative are same charges. They do what? They repel each other, as well as a positive and a positive, they also repel, right? So X no Y are move towards each other because of opposite charges. The spheres are now allowed to touch each other. After touching, they move away from each other. So 10.3 state the principle of conservation of charge in words. So now with 10.3, the principle of conservation of charge is the net charge in an isolated system remains constant. So therefore, in an isolated system, if ever I'm a charge like positive x sphere no negative y sphere, ngiwathatshisa which each other, like lama spheres azothatha and then I separate afterwards. No charge will be lost, but izoba maintained within that system. So therefore with 10.4 but they calculate the charge on each sphere after they have separated. If uthatha ama spheres ayi-2 yawahlanganisa with opposite charges, what will happen is that lama charges or lama spheres azoshare ama electrons in such a way ukuthi whatever is in y or the electrons transferred in y komele abe the same as the electrons in x, right? So ngiyabekisa like since we uyabona usphere y, the sphere y has more electrons than bani sphere x. So now uzowahlanganisa ama-electrons azomove from negative to bani to positive. So therefore kuba ne-flow of electrons. Why kuba ne-flow of electrons? So that kuba nani ne-balance yama-electrons between u-x nobani no y. So into izowenzeka-ke la sizothi-ke 10.4, let's do this. Right, like 10.5 is for the charge on each sphere after they have separated, right? So the charge, which is the net charge Q net, assume Q net, yothatha sphere X, imhlanganise no sphere Y, the charge on sphere X ngihlanganise nale charge on sphere Y ngidivide ngo 2. If it was 3 divide by 3, if it was 4 divide by 4, so on and so on. So the charge on X is positive 4.8 times 10 to exponent minus 18 plus minus 4.8 times 10 to exponent minus 18 divided by 2. Answer yethu kuzoba equal to, let us calculate. So kuyoba, okay, let me do this. Yabona ngathi iyaphapha le calculate. Okay, 4.8 times 10 to exponent negative 18. I think ngifaka ama brackets. Lana it's a plus open bracket minus 4.8 times 10 to exponent negative 18 divided by 2. This is equal to 0. Is it? Is equal to 0. Alright, now wait. Let's go back. Lana, it's actually 4. It's actually 4. Sphere X, 1 of 4 plus 4 times 10 to exponent minus 18. This is equal to, so lana ngenzi error. I made an error. Tingilungise masinyana. Lana it's 4. So lana it's 4. Our answer is negative 4 times 10. So lana it's negative 4 times 10 to exponent negative 19 coulomb. So therefore this is the net charge. Each sphere is over a charge of this much, right? Is over a charge of this much. Ngoba lama electrons must be evenly distributed after they have separated. So our Q net, or the charge on each sphere, is over minus 4 times 10 to exponent minus 19 coulomb. So this concludes our video. 10.4 is the last question for question 10. Thanks for tuning in. Thanks for watching. Nanga we enjoyed this video. Just leave a like, ungakhohlwa ukushare nabangani bakho. Let us talk in the comment section nangabe une question, if ever awunderstandanga anything la, if ever ngibhedile, let us talk in the comment section. So yeah, asibonane on the next video. In the description below ungakhohlwa uzothola amanye ama questions for this question paper. So thanks for watching, asibonane on the next one.